Okay, welcome to the final session, everyone. So we are, right, compared with the programme, we're about 15 minutes earlier for this final session. So Kate Canham's the first talk, but then slotting in after Katie McFall will be Judith Kinnaird. And then we're back on the programme, sort of 15:30 will be Tom Buckle, Tim Dunnett, Tom Blenkinsop. And then if there's still an appetite, I'll do a talk at the end to make up for one of the ones that got taken out earlier today. Okay, so I'm Dave Howell from the University of Leicester, so my pleasure to chair this final session. So we're back to the Bushveld, and in particular the northern Bushveld, with a little excursion to the Bethel Limb in the middle. So the first speaker in this session, part of the NL4D project, which we heard about yesterday, is Kate Canham. So over to you, Kate.
Cool, right. So I'm going to be talking about PGE and sulfide in the deep critical zone at Sandsloot in the northern limb of the Bushveld complex. So you probably saw this image yesterday if you were at Erin's talk. So this research is part of NL4D, which is looking at the northern limb. And this research in particular is part of work package 2, which is looking at the mineralogy and the metallurgy of the critical zone. And what I want to point out here is that the critical zone is where the flat reef is hosted. And as we go down dip in the critical zone, the critical zone gets thicker and it increases in grade. So the area that we're looking at is Sandsloot. So this is Anglo's current open pit. And here they're exploiting the flat reef where it's near surface. But there's an area of new drilling that's immediately to the west, and that's targeting the down dip extension of the Platte Reef, where we've got that increase in grade and increase in thickness. So that's where this study is focused. So at Sandsloot, this is what the rocks look like. So this is all critical zone, and we've got an upper PGE reef where we have platinum and palladium and copper and nickel, and it's kind of like phosphatic peroxides, serpentinized peroxides, all that sort of thing. And then as we move further down into the critical zone, kind of several hundred meters beneath it, there's a base metal zone. And here we get the PGE grade drops off, but we retain the copper and nickel grade. You can see we've got these zones localized where we have semi-massive to massive sulfides. So the reason why we're interested in this is because this is new drilling. So the stuff at Sandsloot, the PGM assemblages and the sulfide tenors haven't been characterized. So we need to understand that and characterize these. So that's really important for processing of the ores. And we want to understand how, as we go deeper into the Platte Reef, how mineralogy changes. And then we want to see how different processes have affected the geometallurgy of the ores. So what effect does contamination have? And what have the hydrothermal effects been on these ores? So if I run through the different zones and what the sulfides are like in them. So these are mineral maps, and you can see the sulfides are highlighted in the red, purple and pink. So you can see we've got finely disseminated sulfides, quite typical magmatic assemblage of pyrrhotite, pentlandite, chalcopyrite. They're quite pentlandite rich, and that pentlandite is very palladium rich as well. And we get like a lot of silicate alteration, which is quite like normal for northern limb rocks. Then if we compare that to what we find in the base metal zone, so again, these are mineral maps, and the immediate thing you can see is there's a lot more sulfide. So it's kind of 3 to 5% volume sulfide, but then these samples are from where we get locally, it'll be several meters of semi-massive to massive sulfides. And you can see there's a lot more pyrrhotite compared to pentlandite, so these are lower tenor. And they're more palladium poor, the pentlandite, in the PG reef. But interestingly, they're cobalt rich, the pentlandite is. And kind of there's lots of interesting and cool textures going on here. So we've got like base metal sulfides invading into the silicate mush here. We've got all these loop textures around the pyrrhotite. Here we kind of have like separation of the MSS and ISS, with like the copper rich portion kind of seems to be separate and then like preferentially going into the silicates. We've got this like this like wormy texture here with the sulfides integrating with like silicates, which is a really interesting texture. We're still working on these, so if anyone has any ideas about how these textures form, I would be happy to hear. So next, if we look at the PGM in each zone, so this is platinum palladium through the PG reef, so about 30 meters here of the reef. And each of these bars represents one sample and the PGM assemblage from that sample. So you can see we've got samples where we've got more platinum, palladium, bismuth, tellurides and more gold, silver minerals. And then we also get PG alloys, so that's mainly lead, but also tin, PGM as well. And then we have samples where we have much more palladium and platinum, iron minerals, and also laurite. And kind of a thing to point out here is how the number of grains and the total areas compared to the grade doesn't always match up. So we might be getting a bit of a nuggety effect, but also we're doing laser work as well with the sulfides. We need to do a bit of a mass balance to work out like exactly where the PG is held. In terms of the textures, so we have primary PGM where we've got PGM held within sulfides. We've got things like laurite, platinum, palladium, bismuth, tellurides on the edge or within sulfides. We get this texture here. So we find platinum and palladium iron alloys, and they form this symplectite texture within the sulfide. And we also see this with magnetite as well. So perhaps we've lost sulfur, so that's why we're getting this texture here maybe. And then we also get these secondary alterations. So we see platinum iron redistributed within secondary silicates, within serpentinite veining here. And we also see antimonides and stuff, which are kind of secondary PGM. So if we compare that to the PGM assemblage we find in the base metal zone, again, this is each of these bar charts, like each of these bar represents one sample. And you can see we have a lot of more of a pink coloured bars. So that's things like laurite and things of the Hollingworthite, irisite, platysite series. And these are IPGs, so osmium, iridium, ruthenium. So that's distinct from what we see in the PGE zone above, where we have platinum and palladium PGM. In terms of where we find them and what they look like, this is like quantitative data. So we can see they're mainly hosted on sulfide boundaries or sulfide hosted. So here we've got like iridium arsenide hosted in sulfide, laurite grains hosted on the edge of pentlandite and pyrrhotite. So these have a close association with sulfides. So kind of the takeaways from this is that in the PG reef, we have a zone of high platinum and palladium. And here we have disseminated sulfides, and these are really high tenor, high palladium bearing pentlandite. And the PGM assemblage is platinum and palladium bearing. If we compare that to the base metal zone, we have a much lower zone of platinum and palladium, and here the sulfides locally are semi-massive to massive sulfides, and these are much lower tenor. So these are palladium poor but cobalt rich. And here we have a different PGM assemblage, so it's IPG opposed to the PPG that we find in the PG reef. So kind of what we want to understand here is, why does that base metal zone beneath have an IPG PGM assemblage? Why has the IPG not gone into sulfide? Why is that forming PGM instead? And then we want to understand, is this something, were these originally the same and we've had IPG and PPG decouple? Is it something that's gone on afterwards? Have we got some sort of sim magmatic high temperature process going on, or is this hydrothermal kind of fluids afterwards? Or kind of, is this base metal zone more sulfide rich just because of we're nearer the base? And are we like in a depression? Have we had like sulfides trapped there? Is that just why we've got more sulfur there? And then around Sandsloot, how does alteration relate to different PGM species and the sulfide tenors? How does it vary as we go down dip and along strike? Can we use different alteration types with different PGM species to kind of as a proxy or something like that? So yeah.
Okay, you've left yourself time for questions.
Yeah.
Have we got any questions?
Yeah, thanks for this nice talk and the nice data. I have a question regarding your platinum iron alloy, which was intergrown with this platinum tellurium phase with this weird texture.
This one.
This one and the other one, yeah, on the right. What is the surrounding? So there's pentlandite, and are these some iteration silicate or so on? Because we observe similar stuff in Great Dyke and Bushveld and near surface stuff.
Like this stuff here.
No, on the right, the one on the right. Or
Silicates, I can't remember.
but not primary, maybe.
No, not primary.
Okay.
But then we do also find them just in the sulfides, which are then primary sulfides. So
Okay, interesting.
yeah.
Good.
Hi, thanks very much. I wanted to ask the pyrrhotite and magnetite you have, how well do they correlate the susceptibilities with any of the mineral content? Because the pyrrhotite should be quite magnetic.
Could you say that again, please?
The pyrrhotite should be magnetic. And so I'm wondering, do your susceptibility values correlate at all with your grades or anything, or do you see any relationships, or have you recorded magnetic susceptibility?
I haven't.
Okay,
No.
never mind.
Yeah.
Any questions?
How far, so I'm just trying to understand where the base metal zone sits. How far above the Transvaal does it sit? Is it well within the magmatic stratigraphy still?
Yeah, so it varies, but they haven't, in a lot of the holes, we don't actually go down as far as the Transvaal, so it's there, and I don't know how much further it goes after that.
Yeah, good talk. Question the base metal zone again. I noticed, so the question is, why is it so IPG rich and platinum palladium poor? I noticed it's also quite chalcopyrite poor. Is that correct? Or
Yeah.
was it a miss?
Yeah, no, it is fairly chalcopyrite.
So then the question is, is it possible that the ISS has percolated further down into the floor or in?
Yeah, maybe.
It's not unusual, of course, that you got a base metal zone at the bottom of the flood reef and flood reef. I think Dave, for example, has shown these things in the past. The base metal enrichment at the base of the flood reef and flood reef.
Yeah.
You have shown that in the past. Is it similar there that it's IPG rich, platinum palladium poor?
No, I've not seen anything like that before.
Weird, huh?
But this might be a nice little segue into the next talk.
Okay.
So
That was a miss.
is it quick, Moose? Go on then. While we're changing over.